All right. Example 7 says, if the velocity of a vehicle at time t seconds is measured in meters per second, what are the units of acceleration? All right. So first of all, what is acceleration? Acceleration. When we step on the accelerator, right, we change our speed. Our speed increases, right? So it's the rate of change of velocity. So let me write that down. Acceleration is the rate of change of velocity. All right. So essentially, velocity. All right. So essentially, it's the derivative of velocity, right? We take the derivative of velocity and we get acceleration because that's the rate at which velocity is increasing over time. So, since acceleration is equal to the derivative of velocity, then we can find the units of acceleration by using what we learned before, which we're just going to take the units of velocity in meters per second, and we're going to divide by the time, right? The input is time, which is measured in seconds, okay? So we have meters per second per second. Now that looks a little funny written like that. It's, you would describe it as meters per second, or it's often written as meters per second squared. You can kind of treat these units like fractions, right? So if we have meters divided by seconds, and then we divide that by seconds again, we're going to get meters per second squared. All right, so meters per second squared, or like I said, you can read it out as meters per second. Oops, put a little space there. Second per second. Okay, so rate of change of velocity, meters per second per second. All right. Okay, so now let's look at this last one here. Example 8. The electrical energy consumed by a refrigerator measured in watt hours. Okay, so that's a unit, watt hours. It's watts times hours, okay? Watt hours is watts times hours. Is given by, the function e of t, where t is in hours. So what are the units of e prime of t? Okay, so we're taking the derivative. Now the units of e are in watt hours. Okay, and we're taking the derivative with respect to t, so we divide by hours. Now, because watt hours is watts times hours, we can actually cancel the hours part of it, and we get watts. So the units are often written as just W for watts, or you can write it out as watts. Okay, so watts, that gives you the rate at which energy is being consumed, whereas energy is just energy. Energy is in watt hours. So like if you were to look at your electric bill, if you live in an apartment and you get an electric bill every month, they're gonna charge you based on your watt hours, or sometimes it's kilowatt hours, right? So thousands of watt hours. But when you look at if you look at the nameplate of a refrigerator, or even when you buy a light bulb, it usually tells you the watt, which is the rate at which that light bulb consumes power. Okay? Anyway, so the derivative of watt hours gives you watts. All right, that's all I have for you today, and we'll see you in class.